Hi, welcome to BriForum, and welcome to my session on HTML5. I think we're about halfway through BriForum. I know I've been enjoying myself a lot. Oh, okay. How do I crank up the volume on this?
Well, you rotate something.
Yeah, probably.
We can speak louder, too.
Yeah, okay. Everybody tells me I have a loud voice, so I could probably do it that way as well. So as I said, we're about halfway through BriForum. I know I've been enjoying myself a lot. I hope you have been too. I especially like Brian and Gabe's presentation before. I guess a lot of you probably have been there as well. And this session, the session on HTML5, kind of is related in a sense to that session, in the sense that a few years ago, if we were at BriForum, then this session would have really been out of place, because this was a conference about Citrix and then about VDI, and what do those things have to do with HTML5? But if you attended Brian and Gabe's session, that you saw that the IT world is evolving, and this conference is evolving along with it. We have sessions on mobility, we have sessions on EMM, and if we're thinking about the whole concept of enabling users and application delivery in general, then HTML5 fits right in. Certainly, it's the case with applications that we're currently developing or applications that we're currently deploying going forward. But as we'll see, it's also to an extent the case with enabling access to existing applications as well. In any event, I personally am really into HTML5, and I hope that in this session I can convey why this is. So a few words about myself. My name is Dan Shappir. I'm CTO at Ericom Software. We are a remote access company, which means that we provide products that are comparable to products that are provided by Citrix and VMware, or that enhance products from VMware and Citrix. If that's interesting to you, you can talk to me afterwards. But what's really important in this context is that we have an HTML5 remote access solution, and that led us to invest a lot of resources into learning HTML5, understanding HTML5, following with the latest trends. Personally, my own interest in HTML5, or HTML in general, and web in general, goes way back before then to previous companies that I worked at. I've been doing web application development in a sense since around something like 96 or 97. So I've been doing it for quite a while. This is my Twitter account. So for the last year or so, I've been on Twitter and have tried to be active, but not too active. So hopefully if you follow me, you'll find it interesting, but not overbearing. I also have a blog, which I don't blog to as much as I should. But I have some content there as well that I hope is interesting as well. I'm a 5-time BriForum speaker. Actually, this is my 5th time at BriForum, speaking both at this session and another session immediately after this one, which is kind of related to this session, which I'll be doing with Brian Katz over here. And we'll be talking about mobile application development, and this certainly is related to HTML5 in the sense that HTML5 is one of the technologies that you can use to create and deploy applications to mobile platforms. I love JavaScript, and I love the open web. And by open web, I mean the web that's built on open standards. And as we will see in this presentation, this is a really significant thing, and this really differentiates the web from the other platforms that we're familiar with. Because all the other platforms that we're talking about in this conference, certainly the Microsoft platform Windows, but also platforms from Apple and Google, like the iOS or Android, all of them are not open in the sense that they belong to a vendor, and that vendor makes the rules. There is no such thing as a standard body that governs the standards and tries to promote interoperability between various vendors. Now, obviously, this can result in a situation of something that is designed by committee. But I do think that in the case of the web, to a great extent, we've been able to avoid this, and I'll touch on that as well. By the way, if you have any questions during the debate, feel free to interrupt and ask me. We have a lot of content, but I do really want to get your feedback and I do tend to ramble. So if I don't notice you, then make yourself seen and heard. This is really for Brian as well. This session is obviously about facts, but it's also very much about my own opinions, and I am opinionated, and I like to discuss my opinions, and I like to argue them. And Brian, this is for you. Even if you beat me, I'll still enjoy it. So, and I won't admit it. So we'll see how that goes.
You just did, so problem solved.
Okay. Okay, so we'll start with talking about where HTML5 currently is. And the thing with HTML5 is that it's really advancing rapidly. And that, again, kind of differentiates it from other technologies that have been governed by committees. In the sense that it's kind of running forward all the time. I think I once spoke with Brian Madden when I said that with HTML5, it's almost, in the context of the features, it's almost like getting a new version of Windows every month. You literally get all these features all the time. And it's really interesting to see how all of these advances are then brought into the standard. So HTML5 has been a lot in the news of late. And here are some of the more interesting things, at least in my opinion. So for those of you who don't know, W3C is the standard body that governs the web. And it announced that the HTML5 spec is feature complete. In terms of its content, it's done. They're not adding anything new into HTML5. And that seems kind of contradictory with what I said before about how HTML5 is constantly advancing. Well, the thing is that they've effectively drawn a line in the sand saying this is the thing. See, the thing to understand is that HTML5 is essentially just a new version of HTML. And there was HTML4, there's HTML5, and you could say that we're starting to work on HTML6 or 5 point something. So in this case, HTML5 is kind of like a line in the sand where they're saying all these features up to here, those are part of an official specification, but that does not mean that we're stopping and not continuing to work on advancing and enhancing this technology. And indeed, more or less immediately after announcing this, they released the first draft of HTML 5.1. So this is exactly an example of where we're continuing to see advances despite the specification being set. Now, really, from my opinion, there are two main things driving this. First of all, HTML5 was originally announced in 2004, and then they said we're going to give it 10 years to create the standard. So they really wanted to be able to meet their commitment. The other thing, though, which is, again, good in my opinion, is that now that we have a standard, browsers will need to adhere to this, because that's another thing that's changed. In the past, we've had this race between browsers, at least until IE1, and part of that race was adding proprietary features, just making the browser better. Now, one of the main things that people do look at when selecting a browser is the issue of how HTML5 is it. And in this context, it does mean how compatible it is with the standard. So having a standard is definitely a good thing in my opinion. We've heard, this has been in the news, that maybe HTML5 is actually dead because Facebook and then LinkedIn dumped HTML5 in favor of native applications on mobile devices. What does that actually mean? Well, the first and very important thing to remember is that what they really dumped were the hybrid apps. You know, both Facebook and LinkedIn obviously still have websites. And if you go into these websites, they definitely use HTML5 features in them. So you can't say that they're no longer doing HTML5. What they did do is when they created the original versions of their mobile applications, they created them as hybrid apps. And I'll talk more at length about hybrid apps if I have time towards the end of this presentation. But that really means putting like a web browser within a native container. Or think about a native application that's using a web browser as its interface. And they did that because that way they could reuse the code that they created, the HTML5 code that they created for their website within their mobile applications. And the purpose of that was obviously to reduce the amount of work and also to create a consistent interface between all their applications. Well, it turned out that it didn't really work for them as well as they wanted to. The primary issue, by the way, had to do with memory management. The browsers can be very memory intensive, and in their native applications, they were trying to use web technology to replicate native interfaces. And especially the whole infinite list concept, if you're familiar with it, with Facebook and LinkedIn, where you can or Twitter, where you can just scroll forever. And it turns out that this wasn't very conductive to HTML5, and eventually they just went native all the way, or almost all the way. Yes?
So it sounds like instead of it being a bad reflection on HTML5, they just did a crappy program.
Sorry?
Instead of this being a reflection on HTML5, it sounds like they just did some crappy program.
Well, you know, it's arguable because there certainly are limitations. If you are going to, first of all, you know, I won't bash on Facebook's and LinkedIn's developers, and they do have some of the best developers in the world. They can't afford to pay them. So there are some intrinsic issues with using a web browser to replicate a native interface on a mobile device. Especially, as I said, in certain scenarios where you have a lot of content within the same page, and it can really eat up your memory, and there are not enough controls currently in the browser to really manage how much memory your page is consuming. So in that sense, you could say that they went with the quick solution of having a hybrid app and then reusing the code that they already had because of their website. And then when they had resources available, they could then go fully native and do it that way. Look, obviously, anything that you can do in terms of user interface in a web application, you can also do in a native application. It's just a question of how much effort you're willing to put into it. The other thing, okay, so that covers that point. Another thing that was in the news, Microsoft released IE10 for Windows 7. Now, obviously, when Windows 8 came out, like they did with every previous version of Windows, they put a new version of IE in it. What was interesting is that they then went back and also ported that version back to Windows 7. And that just goes to show how important the standard is becoming, because IE10 is much more standard compliant with HTML5 than IE9 was. And really now, the interesting thing is that the IE10 market share on Windows 7 is actually larger than surpassed the IE9 market share. That's data that I got from sorry? No, it's not. And that goes back to this point, that on XP we're stuck with IE8 forever. The thing, we'll get to the IE market share in a bit, but it goes to the fact that even with IE, we're seeing progress. You know, IE11 beta is on Windows 8.1. They've added even more HTML5 features like WebGL, which they originally said that they were considering not doing, so now they've actually done that. And IE10, they also announced IE11 will be available in Windows 7 as well. So if IE10 market share surpasses IE9, I think it's fair to assume that IE10 will be replaced by IE11 when it comes out, and the IE9 market share will continue to shrink. So in effect, it's bringing us to this situation where to a great extent, the vast majority of the browsers will be HTML5 compatible or capable. Which brings us back to this slide, which I really like. I know correlation does not mean causation, but it's still interesting in my opinion. Again, there are two important takeaways from here. One is that we can use HTML5 features in more and more browsers. The other thing is that HTML5 is not this monolithic thing. It's a lot of features. And you get some of these features in some of the browsers, maybe some not, but you don't have to use all the features in your web applications. In fact, you probably shouldn't. There are great HTML5 features that you can use already that also degrade very gracefully. For example, whenever I'm in a website or a web form on a in a browser on a mobile device, and I click a field where I'm supposed to, let's say, provide an email, and I don't have the @ sign in the keyboard and I have to switch, that makes me angry. And it makes me angry because all you need to really do is in that input field in the HTML, just set type equals email, and you'll get that @ sign in the mobile browsers. And it's backward compatible in the sense that if it's an older browser that doesn't understand the email value, it just treats it as text and still works. And that's a small example of a single HTML5 feature that you can use in any browser today, makes the user's experience that much better, and you don't have to do Canvas or WebSockets in order to take advantage of this. Okay, so what are the main trends in HTML5? One is a feature or approach known as responsive web design. The fact is, the thing that differentiates HTML5 or the web from all the other development platforms is that in terms of the hardware that it's running on, the endpoint, it's agnostic. And that means that it could be a laptop like this, it could be a phone, or it could be anything in between, a tablet. And all of these devices have different screen sizes. In fact, the same device can have different screen sizes depending on the orientation in which you're holding it. So responsive web design is all about the concept of designing your web application in such a way that it can work on any screen size in any orientation. And HTML5 is being enhanced in such a way with stuff like media queries that makes it much easier to do than it's ever been. And usually the approach is to start by designing for the smallest possible screen, and then as the screen grows, add more and more features so that the users have all the basic functionality that they need, even if they have a small screen. But then as the screen expands, they get direct access to features that otherwise maybe would require them to scroll or to switch to another page. I have an example here of such an application. Let's see if I can open it here. See that it's... Oh, I hope I did not lose my internet connectivity. No, I'm still on the network, it seems. I don't know, strange. Yeah, and I'm even getting emails. So I must be. Let me just close my email, which I forgot to do. I apologize for that. Why doesn't Outlook want to close? Now it closed. Okay, so there are a lot of examples online about this. If you search for responsive web design, you should find a lot of examples. And what's cool with many of these examples, you can actually literally take you don't need to test it on different devices. You can literally take the window and resize it and see how the content flows to utilize the extra space, which means that it's a good thing even if you're running these applications on Windows, because even then if the user resizes the browser window, you don't get this annoying scroll bar. You just get the content realigning itself to make better use of the available screen real estate. Any questions about that or any other? Okay. Another interesting approach is mobile first. This is kind of related to the one before in the sense that, again, it means designing for the smaller screen. It also means designing for touch before you design for mouse and keyboard. It means, for example, that mouse over effects, which used to be so popular in the web in the past, are probably not such a good idea anymore because there is no mouse over effect in a touch interface. Touch interface also needs to be much more interactive in many ways because when somebody drags something with a finger, it needs to really move along with the finger, otherwise it becomes really annoying. When you're typing, you can live with a certain delay, but you can't live with it if you're actually just dragging something with your finger. Progressive enhancements, again related to that, it means understanding what the minimal feature set that your application requires is, and then adding features progressively per the capability of the platform that the application is running on. And finally, offline. This is one of the big changes that's associated with HTML5 compared to previous versions of HTML. I mean, how many of you even think about the idea of being offline, yet still going into the browser and selecting a website from your bookmarks or your favorites? Seems unnatural. But with HTML5, we can do that.
Telcos are going to love it.
Sorry?
Telcos are going to love it, especially up in Canada where we still don't have unlimited plans on the internet on mobile devices.
And in fact, for example, if you're using an application like Gmail, Gmail, you can open it when you're offline. You can write new emails while you're offline. You can read at least some of the emails while you're offline. And when you go online, it will actually synchronize itself with the online server, the web server. Google Docs is another example. Now, this does require a change in thinking in how HTML5 or how web applications are created and designed. This change is taking place, not as quickly as we would have liked. It also brings in some interesting concerns, which I'll talk about later, because if you can work offline, it means that the data needs to be available offline, and that could raise security concerns. But that's definitely one of the big changes that's happening around HTML5. Yeah?
In the case of Google Mail, let's say, is that all within the HTML5 standard to do that functionality?
Yeah, yes it is, and I'll touch on that later. What this does mean is in the same way that there's a growing demand for mobile developers, there's a growing demand for web developers. And in fact, if we're looking at it in relative terms, if we're looking at how the demand has grown relatively, the demand for web developers is even outpacing the demand for mobile developers in terms of percentage-wise growth. And it can be a problem. It's especially a problem because
I just had a quick step back, but the offline access for HTML5, that's built into the standard today?
Yes, it is. There are a couple of standards around that. I have a slide about this later on. I'll touch on it. We'll see how much we can cover it. But yes, there are several technologies, not one technology, several technologies that are part of the standard having to do with caching either the web pages themselves or caching data used by the web pages, which is really two separate things if you think about it. One of the problems with developers for HTML5 is that historically a lot of the people doing web have been web designers, not developers, and a lot of the developers aren't familiar with web technologies. So we're kind of at an inflection point where developers are starting to think, hey, it's really good to understand HTML and JavaScript and stuff like that. And there are also other alternatives coming around which are enabling the actual porting of existing application or reusing existing technologies like C++ for creating web clients. We'll touch on that as well. Another thing that's in the news is there's an interesting browser shakeup. And this shakeup really has to do not so much with the browsers as within the engines in the browser. The engine is that part of the browser which takes does the HTTP download and then renders the HTML, the inside of the window. And that's kind of distinct from, we could call the Chrome of the browser, which are the menus and the dialogues and the favorites and the stuff like that. And historically, there've been, or in the past, there have been 4 major engines. There's the engine inside IE, that's a Trident, and their JavaScript with this Chakra. There's the one that was used by Opera, I forget its name, Dragonfly or something like that. There's WebKit, and Mozilla. Both WebKit and Mozilla are open source. The other ones were closed sourced. Microsoft obviously has always been closed sourced. Now there's been an interesting shakeup. So shakeup number 1 is that Google announced that they're breaking away from WebKit. Basically what they did is they forked WebKit. They took the existing state of WebKit, broke it apart, so they started with a copy of WebKit, but from this point on, WebKit and this new copy, which is called Blink, are advancing separately. This was because Google wanted to advance more quickly in terms of adding features and functionality than Apple would allow them to do with WebKit, and also because Apple kind of owned WebKit, and also because Apple required that they support very, very old versions of Macs or iOS that Google did not want to support anymore. And then what happened before is that Opera announced that they're abandoning their own engine, joining WebKit, but when Google broke away, they immediately announced that they're actually going with Blink, which tends to lead to the assumption that Opera knew what was going to happen. So now we have both Chrome and Opera going to be using Blink as their engine. By the way, what's interesting about this is that Opera are also supporting older versions of Android that Google are not supporting with Chrome. So you will be able to install a newer capable or feature-capable browser on older versions of Android by using Opera instead of Chrome. Apple are continuing with Safari, so Safari will continue to advance as well. And Firefox, well, effectively what they're doing is they're sticking with their Mozilla engine, but they've announced that they're going to rewrite it. And they're going to rewrite it using a new development language that they created called Rust, because they want to do it. They're looking forward. They look at the new devices today, which are all multi-core, and the engines were designed for the x86 technology originally, which was not so multi-core, and they want to take advantage of all these smaller processing units to make it faster. And interestingly, this project is at least partially funded by Samsung. So it's interesting to see all the major players in the industry, really, the Microsoft, Google, Apple, the open source community, and now also Samsung, also involved to one way or another with the advancement of web technology. There are other vendors even beyond these ones with browsers of their own. BlackBerry has a browser. Amazon Kindle has Silk. They're all, to one extent or another, based on these open source versions, mostly on WebKit. But it's interesting to see how we have all these vendors that are all really pushing forward their browser technologies, and how vendors like BlackBerry see the browser as a means to promote their system. I mean, we have fewer apps, then we can compensate for that by having perhaps a better browser. Competition is definitely a good thing. That's one of the things that's really pushing this technology forward with newer features and capabilities. But obviously, it does mean that fragmentation is a risk and can remain an issue. And again, the fact that we have a standard body helps there, but I won't stand here and tell you that you can use an HTML5 application with all the bleeding edge features and not expect any cross-platform problem. On the other hand, I can tell you that there are a lot of HTML5 features that you can use, which aren't necessarily on the bleeding edge and definitely work everywhere. And in fact, we ourselves have been able to build a remote access client, which is a very sophisticated application, well beyond where most HTML5 applications go, and it does work on all these browsers. So it is definitely possible. And again, going back to the standard, what I said before. In addition, there are a lot of good libraries out there like jQuery and others that also make it much easier to create cross-browsers and cross-platform web applications. And since all the browsers, even IE, have adopted the self-update approach, it does mean that if something doesn't work in this version of this browser today, there's a good chance that it will work within a month or two without the user maybe even necessarily having to do anything because the browser will just update itself. It does also mean that browser versions are dead. Does anybody know which version of Chrome they're on? I assume most, you do? Which one? 27, okay. Okay. Okay, so that's because you're abnormal. I said that's because you're abnormal, the fact that you know what your version is. Most people don't know and shouldn't know what the version of the browser is. The only real difference is IE, when unfortunately, even with the self-update mechanism, we still need to know which version the user has. Oh, I just wanted to show, let's see if this will work. Where's my? The browser fountain. So I just put it here because it's cool. It shows all the logos, and it uses HTML5 to do the animations. So to sum it all up, I think even though we have so many browsers, the future actually looks good in the sense that the browsers are the browser manufacturers are striving to work together and come to agreements and consensus when it is possible. And we will see a very cool example of that, again, if I have time later in the presentation. Firefox OS. I don't know if you've heard of this. This is a new version. This is yet another mobile OS created by Mozilla. Used to be called Boot2Gecko. Now it's called Firefox OS. They've actually released it in Spain, I think. So you can actually buy phones that have this new operating system on it. It's 100% web tech, which means that all the apps that are running on it are built using HTML, JavaScript, and CSS. No native applications at all. They look like native applications. They run like native applications, but they're all web technology. It's completely open source, obviously. But what's much more important from my perspective is that it's all built on open standards. And what does that mean? It means that they needed to enable web applications, for example, to send notifications. You know, like you received a new tweet or a new email. And in order to do that, not only did they implement the code for it, but they had to extend HTML5 for it, because there was no HTML5 API for sending a notification into the mobile device. So they created the API. But then they submitted that API back to the standards body, where it's being debated by them and Google and others, and a certain version of it will be accepted. And once it's accepted, it will go into Chrome, and then it will go into Safari, and then it will go into IE, and then it means that we will be able to create web applications that send notifications and work on any mobile platform, not just on this one, which is a good thing because I doubt that this thing will be as successful as iOS. Just a few more words about it. They target the low-end market. They're thinking about the third world, you know, having this run on very, very cheap and low power devices, which is again interesting because we usually don't associate web technology with low power devices. So that again goes to show how much the driver engines have advanced, that you can do all these CSS effects on devices that are actually much weaker than an iPhone. And some of the vendors that are supporting this thing. Okay, now it's time to poke a bit of fun at Gartner. Gartner Catalyst just ended, so I guess this is a good time to do it. Everybody here familiar with the Gartner hype cycle? It's actually a fairly smart thing. The idea is that you get a technological trigger. You have some sort of a need, which causes eggheads to come up with ideas of technologies that can address this need. And when a technology does appear that does that, then everybody really gets really happy about it. At least first you have the early adopters, they rush to get it. Then the press hears about it and they start hyping it. Then your CIO hears about it and wants to buy it. And pretty soon you get to the peak of inflated expectations where everybody assumes that this technology will cure cancer and heal the world. And then, we meet reality. And we understand that, like every technology has limitations. It can't do everything. It can't address all situations. Also, the press, have hyped it as much as they can. So now it's time for them to start bashing it. And then you have the technology kind of fall into the trough of disillusionment, where everybody says, okay, this technology really isn't, what we hoped it would be, and it's a pile of crap. And, now some technologies actually just drop off the map completely. Others kind of make it through the trough of disillusionment. People say, okay, we understand the capabilities, we understand the limitations, now we can make actual real live use of this technology, and then you get to finally to that plateau of productivity where hopefully the technology perseveres, at least until it's overtaken by something else. Now I've took some information from Gartner about where they put various technologies that we're familiar with on this graph. So quantum computing, is very early stage. HTML5, according to them, is really close to that peak. It seems that BYOD is slightly beyond the peak, according to Gartner. VDI is squarely in the trough of disillusionment, and consumerization is starting to approach that plateau of productivity. Now, before we say anything else about HTML5, I find it very interesting that in a graph from 2012, they put VDI in the trough of disillusionment, where only 3 years before, they said that they project a $50 billion, it should be B, not M, $50 billion market for VDI.
Can you put all these technologies in the same graph? I don't think you can.
First of all, I didn't. Gartner did.
Yeah, I know, but it doesn't make sense. This graph. Time though, they updated everything.
Yeah, but yeah, obviously the points don't advance on the graph at the same rate, and obviously the peaks and the troughs aren't the same for every technology. So this is just a consolidated representation. But again, basically what you're saying is this is a projection that they update their 6-year projection every 6 months, which makes it, why do I need the projection then? But again, it's.
They're right though, because they did a massive prediction about VDI, so it's very funny.
The thing is, though, I put it here because I really don't agree with their projection for HTML5 either. And there are two main reasons why I don't. Reason number one is that HTML5 is not a technology, it's a collection of technologies. And I can put the various technologies that comprise HTML5 at different locations on this graph. WebRTC, which again, if we have time, we'll talk about, is very early. CSS3 is right now everybody's really excited about it, so it's right there at the peak. Video, which was one of the main catalysts for HTML5 to begin with, that turned out to be a big problem because of all the proprietary technology and patents around videos. So instead of solving the video problem, we're even in a worse place than we were before. And HTML5 forms, on the other hand, this technology is really mature, and we are really entering the plateau of productivity with that. So if I can draw a line, HTML5, if I average all the different technologies, it's just a graph kind of going upwards. So that's my first disagreement with Gartner on this. The second one is that HTML5 is really like a wave on top of a very deep ocean. I mean, even if HTML5 ends tomorrow, we'll all be doing web. We'll all be doing, websites and web forms and web applications. And, if a certain HTML5 feature is useful for me, I'll use it. And I don't really care if it's part of HTML5 or not. So this whole thing is really just this wave on top of a very, very deep ocean, which is the web. Now, my opinion, and by the way, whenever it's my opinion, I put it with red on top, so you know that this is not like, industry agreed facts. These are my opinions. I think that the Gartner hype cycle, as applied to HTML5, is bunk. Now, but the point here wasn't really to poke fun at Gartner, which is really easy to do, and I guess all of you can do it. You don't need me for that. The point really was to stress the fact that HTML5 is happening and continuing to happen regardless of what Gartner or anybody else says about it. And this is the most important thing. From my perspective, HTML5 is the closest thing that we have for future-proof tech. Which smartphone are you using? Android. Will you be using Android in 15 years? We'll see, but you don't know. You don't know. But I can tell you that whatever device you're using, I'm certain it'll have a web browser on it. So that's the key thing. Whichever other platform you're developing for, iOS, Android, whatever, that development comes with a shelf life. And if you take into account that, we used to build enterprise applications for decades, that really is becoming a problem. I mean, if people are switching the platform that they're using, this whole conference is about, what do we do with the Windows applications when we're getting to the point where we're beyond Windows? Well, this is one big, huge advantage for the web that it has over the other platforms. Application architecture, and I'll try not to make it too developer-y. Okay, so these are, now we're going to touch about all this thing about offline and storage and stuff. So these are how web applications used to look like. The actual work that took place in web applications used to happen on the server side, in the web server. You had technologies like ASP, ASP.NET, JSP, PHP, Cold Fusion, whatever. They created web pages which were pushed down to the browser, and then the browser just rendered the page, and that's all the browser did. And beyond very, very simple computations, when you click submit, it just went back and the web server did stuff with the data that you submitted. Now we're switching to a very different model. The model we're switching to is a model where the actual execution takes place on the client side. And if you were at Brian's session and you heard what was said there, every web page is an app these days, because even the simplest web pages have some JavaScript, for example, running in them. So, in fact, what we're now doing, and again, going back to that Gmail example, which is the extreme example, is you download a web page which is actually an app. It runs, and without switching to other pages, it's just sending data queries back to the server side, getting more or less the raw data back from the results of the queries, and then constructing the UI according to the data that it got. So the backend is just a layer that gets the queries, does, let's say, a SQL query into a database, then gets the data back as XML or JSON, and most modern databases already provide this data, the results of the query, as XML or JSON, and then just sends it down to the client. The client takes this data, and JavaScript or whatever running within the browser itself updates the browser accordingly. It goes even a step beyond that, because now in the modern browsers, we even have a small database built into the browser itself. So we're getting to the point where we're actually doing database synchronization between this small database on the client side and the central database on the server side. And the client code can actually go and read the data from the client database, which means it can work offline. And it's also much more efficient because if I made a certain query before and I need this information again, I don't need to get it again because it's already cached in the local database. Now, this may look familiar to some of you if you're thinking about previous versions of how applications or iterations of how applications look like, because this is really how client-server applications work. I mean, if you're thinking about Outlook and Exchange, this is exactly how it works. Outlook is a client that has its own database and synchronizes this local database with a centralized Exchange database. So in a lot of ways, Gmail running in the browser works like Outlook and Exchange work, more than it works like how a legacy web application used to work. And if we're going even further back in history, we can see that we're kind of oscillating, because the old mainframe model was like the web model. So we've got the mainframe model, then we went client-server, then we went web, and now we're going HTML5, which is kind of client-server again. So it's interesting to see how technology keeps on oscillating like a yo-yo or something between these two approaches every time, each with its own limitations or risks and benefits and capabilities. What's interesting, though, in the context of web is that actually you can still do both. Because just because you can do HTML5 model with modern browsers doesn't mean you have to. You could still do the old web model as well. Which brings us to the concept of the single-page application. I mean, if I can write my entire thing as run on the client side, why do I need multiple pages? I just create my entire website as a single page. It updates itself. And this is the concept of the single-page application. An entire web app or website implemented as a single page. No page reloads. Every click you do, you stay within the same page, so it's much more responsive. And the HTML itself is just a template for the data coming down from the server side. Again, I talked about that. So what are the benefits of this approach? The benefits are that it's much more responsive, because when you click something, you can bring down the data in the background while the page continues to be responsive to end-user interactions. With the old way, when the user clicks submit, the user had to sit around and stare at a blank browser window while waiting for the content to arrive. This is not a problem anymore. It's much greater scalability because, again, the server does so much less. We've pushed workload to the client. That's another cool thing. For example, LinkedIn are using the exact same backend both with their web applications and their native applications, because they're just sending down JSON data down to the client, and whichever client technology implemented in, it just renders it accordingly. You get good performance over slow networks, and finally, again, you can work offline. So those are advantages that are associated with this approach. We talked about this before. These are all data persistent options that are part of the standard, although the WebSQL one is being phased out of the standard. This again, this is about persisting the data, not the pages. There are different standards for persisting the pages. There's a standard called App Cache. There's a new one because of limitations with the App Cache model, they're now introducing a new one. I forget its name, but the basic idea is that a website owner can actually write a JavaScript code that controls what to do when a certain resource is inaccessible, whether to get it from the local cache, get it from online, or go somewhere else, or just display dynamically generated local client data to the user instead. These are technologies used to store data, to cache data locally. Cookies, everybody knows. You know what? I won't go into depth because this is not the purpose of this session. I don't have enough time. But as you can see, there are a lot of options. And with IndexedDB, for example, you could literally store arbitrarily large amounts of binary data or textual data on the client side, which brings us to a very important issue. All of these storage mechanisms are not encrypted by the browser. So in the past, where you could assume that if it's a web app, you don't have to worry about data leakage from the endpoint device. If the endpoint device is lost, this is not the case anymore. If somebody comes and says, hey, I have this great web application that I can sell to your organization, and it can work offline, you just think, hey, if it works offline, it means that it caches data locally. It means that if the device is lost, this data is lost as well. So mobile data loss, web apps are no longer panacea. If you don't want local data, if you don't want data cache, you may need to tell your developer, I don't want sensitive data being cached on my endpoint device, because otherwise he might do it. You need to explicitly verify again that either no data at all is being persisted on the endpoint device, or that no sensitive data is being persisted on the endpoint device, or that the web app itself somehow encrypts the data before saving it, or that you're using some sort of a secure browser that adds encryption on top. I hate it because it means that instead of using the standard browser, you're now forcing your users to use a specialized browser. I don't like that, and probably your users wouldn't either. Or finally, you can use an MDM solution to remote wipe your entire device, but nobody likes that. And one more thing, even if the developer tells you, oh, no problem, you need to log in to the application in order to see the data. Well, in all of these modern browsers, you have development tools built in. And the development tools can be used by somebody who's knowledgeable to get at that data without logging into that application, if it's stored locally. Bottom line, we wanted it. We wanted the ability to work offline. We wanted better, more responsive web applications, so we needed the ability to cache data locally. We need to use this feature responsively. That's all that I can say about it. WebRTC. How much time do I have? Sorry? A lot. Okay. If I have a lot, then I can talk about this. I picked this technology because it's a new web technology, very new one. If you remember the graph, it's still climbing up from that initial hype steep. And it's not familiar, but I think this is one of the biggest things that are going to hit the web browsers in the upcoming years. And it is widely supported by the vendors. They're all working there, not necessarily together. I'm not saying it's usable now, but I'm saying that it will be usable.
I'm saying it's usable now, but Apple and Microsoft, because they're stakeholders in embedding, will never. You'd be surprised, and I'll get to that in a minute. Okay, so what is it? Everybody knows Skype, right? Well, one day the browser manufacturer said, hey, why don't we make it possible for the browser to be a Skype client or a replacement Skype client or like a Skype client? Let's, people do chat in the browser. You don't install chat clients so much anymore as you chat in Facebook, and you chat in Facebook using the browser. Why not do video chat in the browser or voice chat inside the browser? So the idea was basically to enable rich, high-quality, real-time communication, audio, video, conferencing, whatever, desktop sharing, between browsers. Skype inside the browsers without any plugin, as a built-in functionality of the browser itself. And several vendors are in fact supporting it. Chrome and Mozilla, while they're working separately on this, and they do have some disagreements, have in fact gotten to the point where they can do chats between their browsers. It's in the alpha or developer channel. It's not in the browser that you currently are using. But I'll show a video in a second where they actually achieve that. Microsoft are actually working on this technology as well. Now, they have a disagreement with the standard or the approach that Chrome and Mozilla have chosen, so they're promoting their own standard, but they're also trying to push it to the standard body. So that means that the argument is not happening in the sense that we're implementing this, you're implementing that, and it will never work together. They are both of them trying to push it to the standard, and eventually a standard will be reached. And it has been shown with previous standards that even when Microsoft disagreed, they eventually capitulated. And they capitulated because they literally have no choice because they're not the monopoly anymore. If you've got browsers that can communicate with each other, running on Chrome, running on iOS, will Microsoft have an incompatible technology on the Windows Phone? I don't think so.
Well, actually, if Apple joined as well, then yes, Microsoft would capitulate, but Apple is strangely silent.
Apple is silent on this for now. Apple, since the Canvas days, Apple does not push the standard, but it does follow the standards because, in fact, Safari on iOS remains probably the best mobile browser so far.
I'm not trying to hijack your presentation.
No, it's okay. Yes, Brian.
Is WebRTC actually a standard yet? It's not a standard yet.
Yes, right.
It's not. It is a ratified standard? It's not. Look, first of all, it's built on some standards because they're using existing video chat standards. So they're not reinventing this whole video chat concept from the bottom up. They're using existing stuff like SIP and so forth. There are changes that they're making, so it's not yet a standard, but it's on the way there. Yes?
I was under the impression there were gaps in the network stack, like WebSockets or other ways of communicating at the network layer. Has that been resolved?
WebSocket, there is a standard for it now that all the browsers support. It is part of the it's part of the HTML5 standard, and there's a standard that all the browsers support.
But does it have, like you did like a terminal presentation.
I may even show it. WebSocket is a technology I'm not going into in this session. It's a technology that establishes a socket-like connection between, or a TCP-like connection, because it is in fact built on TCP, between a browser and a server, which means that it's full duplex and it's not, and you can send and you don't have the HTTP headers all the time and so forth. So it's a great technology, and it's a mature technology because it's supported by all the browsers using the exact same standard. WebRTC does not use it. So it's yet another communication. So we will have HTTP and WebSockets and WebRTC as yet another communication protocol. By the way, we've gotten to the point with WebSockets that it's now being supported by the SSL VPN vendors. So Juniper added WebSocket support to the latest version of Juniper, which is great because it means for us, for example, that we don't have to do an HTTP fallback with all the performance hit that goes along with it when we do a remote Windows session in the browser using WebSocket, if the customer is using SSL VPN. So that's a great thing. Here's a demo. You know what? Because of all this discussion, it's worthwhile showing at least a couple of seconds out of this because it really shows what this thing is. Hopefully we can hear it.
Hi, it's Todd Simpson over at Mozilla. I'm going to show you the latest developments in WebRTC. Here you can see I'm just going to a web page that supports WebRTC. Firefox asked me for permission to use the camera and microphone, which I give it. Call over to our friends at Google.
Hey Todd, how are you?
So the guy on the left is using Chrome, the guy on the right is using Firefox. Okay, I'm not going to let this video go on, but basically what we're seeing is we're literally seeing a Skype session or Skype-like session running within the browser window without installing anything. You saw that there was a thing that the browser asked him for permission. Oh, accidentally. Hope I start from this one. Did I go back to the first one? Nope, I think I'm in this one. Okay. So we can see, first of all, that interoperability we were talking about. So it's not perfect yet, but the fact that we have probably the two major browsers, except Safari, going with it. And IE, I think, will actually join before. I'll answer you in a minute. IE will join before Safari, I actually think. We'll see, though. When Safari will join will be an interesting question, if and when. Although you need to take into account that Apple doesn't really compete in this space, and I don't see what the downside for them would be.
The downside would be is they are a major stakeholder in what's called the MPEG-LA. What that is, it's a licensing pool for MPEG. So essentially, whenever you play video in any application, that developer will pay $4 the MPEG-LA. If Apple turns around and supports the standard Google's version, which is BP9, which is something they probably spend $500,000 are given away for free, license free, free from what's the developer's worst phrase? Liability.
If you're going to go this route, BP9 is actually MPEG-LA, they actually proved recently that it wasn't infringed on part of it.
Yes, and 3 months ago, they paid them a small fortune.
It did.
Yeah, it's the patent issue you referred to.
Yeah, well, that MPEG-LA shut down BP9. This whole thing started 3 years ago. It was pretty much stifled for 3 years because of the MPEG-LA.
Yeah, that goes exactly to my initial point about how it.
And Apple get a cut of
Yeah,
MPEG-LA.
and that exactly goes also back to my original point where video, HTML5 video, is in the trough of disillusionment because of all this thing with the patents and the copyrights and so forth.
In March, Google paid off MPEG-LA.
And the fact that all the
And one future version, and then the next week they released their future version.
And also the fact that if you're looking at mobile devices and the hardware that we have in the mobile devices, that hardware usually supports the H.264, but not other video codecs. You know, this whole thing is a mess, and I'm not going to say that it isn't, but, you know, I'm hopeful. What can I say? Sorry, there was a question before. Yes?
I just have a question about the architecture that's in here. So these two are going to a common site.
No, what happens is, I'll get to that in a minute, okay? I'll get to that point in a minute. Okay. So really, this is exactly this slide. So this really, the whole concept of WebRTC turns the web kind of, I call it turning the web sideways. Because in the past, the model that we had with the web, and including WebSockets, by the way, is that the page comes down, but then if clients need to talk with each other for any reason, like you're playing a multi-user game, you're doing a chat session, whatever, they're talking with each other through the web server. And that cannot work for video chat. So in order to be able to do what they're doing there, they had to introduce peer-to-peer communication. So the original communication does go through the server that creates initial connection, that creates initial connection between the two. But from that point on, if the clients can, then they talk directly to each other exactly like, well, in the same approach that you do with, you know, when you're using Skype. It's or whatever other video conferencing solution that you're using, because it's effectively the same type of approach. They've literally built a video chat client into the browser. And the fact that it's running in the browser doesn't make it any less of a video chat client. No, I'm not an expert exactly. You know, the spec is like yay thick. I don't know exactly. And again, it's built on older specifications that are associated with video chat and stuff like that. I'm not an expert in this field, but there is a sort of an address book mechanism where you get. Sorry? It actually can be used for that as well, and I'll touch on that too. So it's not just for video and audio. It's also for data. They created an API for peer-to-peer data exchange between browsers. You can literally open if you can create a video chat connection, why not create a data connection? It's built on both TCP, it's UDP with TCP fallback, again, because of the video chat protocols. How much more time? 10 minutes. Okay, thanks. I won't run through this entire session, that's for sure. So you can do file sharing. In fact, I've seen an open source implementation of a BitTorrent-like client. You drag a file into the browser, and you share it that way. Isn't technology wonderful? You could do proxyless caching. You could do, for example, one browser downloads the data and then shares it with the other browsers in the same location. Distributed computing. That's why I think this technology is so revolutionary in what it will do with browser-based applications. Make things much easier. You could do these things with native applications before, certainly. It was just much more difficult and not standard-based. So now I can very easily do it with simple JavaScript APIs, and it will be friendly with firewalls and whatnot, because the firewall vendors will want to support this. Yeah, you had a question? Oh, okay. And more. These are some ideas that I had. So bottom line, isn't the web grand? I mean, it's amazing the stuff that we're seeing, what's happening with the web with all these technologies. I don't know how much of this I'll be able to cover in 10 minutes. Some of this content will also be at least touched on in my session with Brian when we talk about different technologies for mobile applications. Let's see how much I can do in 10 minutes. Hybrid applications. That's the concept of kind of taking web technology and then somehow in some way or another mixing it with native technologies. The idea is that the browser runs inside the operating system but is separated from it within some sort of a sandbox. With the hybrid, we're punching holes through this sandbox. So we're either letting native technology into the browser, or we're letting browser technology out of the browser and into the underlying native operating system. And I'll give some examples. So first of all, what is the motivation? The motivation for native moving in is, oh, that's strange. It's kind of, I think this thing went crazy on me. So what's the motivation? One is performance. Native, you can say, at least in some cases, can have better performance than HTML5. So if I can take native code in, I can get the native performance with at least some of the HTML5 benefits. The motivation for HTML moving out is the ease of development that's associated with web platform development. And the advantage of both, for both approaches, is that it's code reuse. I can use the existing native code inside the browser or existing browser code, like we talked about how LinkedIn and Facebook put their web interface on top of their native applications. And I can leverage existing knowledge. If I have developers that are familiar with certain technology, by going hybrid, I can use this technology on the other side of the wall, as it were. A key issue here, obviously, is security. Because if I move code from outside the sandbox into the sandbox, or code that assumes to run inside the sandbox, give it privileges that are outside the sandbox, these can have certainly security implications. So here are some examples. First of all, HTML moving out. How many of you are still familiar with that old HTA technology? Do you know what that is? Anybody still remember what that is? Nobody? Does anybody still remember what HTA is? Yeah, using web. It's HTML applications. Basically, you take an HTML page, rename it to HTA, double-click it in Windows, and it runs in IE, but without the IE border and with no security restrictions. So the concept was that you could use web technology to create scripts that do Windows things. You have stuff like PhoneGap, or now, which is on top of an open source project called Apache Cordova, which basically means this is like the technology that LinkedIn and Facebook were using, putting web interface on top of a native application. Windows 8, if you know, you can actually create Windows 8 applications using HTML and JavaScript. Chrome package applications are basically, you take you wrap web page in a certain way, add a certain JSON manifest, and then it can actually run outside the browser with whatever privileges the user agrees to give it. So it's like a web page running outside the web browser. We'll see if we get to that, and if not, we can talk about it afterwards. Moving in, those things like plugins, ActiveX, those are mostly dead or dying, or we hope they die. There's a new kind of thing called Google Native Client. I probably won't have time to talk about it. ASM.js. Anyway, really running through it, I think I explained this technology more or less, so I won't go into detail. Again, putting a web interface on top of a native application and exposing an API between the native layer and the web layer. So you can create a web application that has all the privileges of a native application, but it's installed like a native application from the App Store. In effect, the user doesn't even know that it's web. It's really a tool for the developers, you could say, a way of creating a web interface, an application interface, but using HTML. So you could call it the best and worst of both worlds. And again, we'll talk more about that in my session with Brian. Just to show this slide, this picture, that's the only reason I'm showing this slide now. This is really Microsoft trying to get more developers to create for their platform. So they're saying, hey, if you know how to create a web application, you now know how to create a Windows 8 Metro application. I don't know if anybody will actually be using it, but it'll be interesting to see. Chrome packaged apps, you know what, I'll really skip that. It's not that important. I think I'll more or less skip everything here because I'll just give my opinion on this. And again, more detail in my session with Brian. I think that innovation is a good thing. The fact that people are taking existing technology and finding interesting and innovative ways of using it and leveraging it is all good. On the other hand, a lot of this stuff goes against this whole open web thing or open standards thing of being kind of proprietary. So I'm skeptical because of that. I thought about showing HTML5 remote access. I probably don't have time for that. I could show it to anybody who's interested later on. There are quite a number of solutions there. VMware came up with their solution approximately. Basically what that means is a client like Citrix Receiver or like a Vue client, but without installing anything running in the browser. You can think about it as a way of taking an existing Windows application and transforming it into a web application by simply putting it on a terminal server or on a virtual machine and then giving web-based remote access to it. The main advantage is no installation, no configuration, works on any endpoint. You don't have to worry you don't have to install or configure anything on the endpoint device. You can integrate it with an existing website so the user can click a link and get immediately that Windows application without having to jump through various hoops and work through SSL VPNs and stuff like that. So that's the advantage of this approach. So I mentioned VMware Horizon View. Citrix have an HTML5 client, but I don't know. Their approach toward it seems to be like a fallback in case of nothing works, so I don't think they're really promoting it that much. We, on the other hand, do. So our client is called Ericom Access Now. There's also a client by a company called Cybello. They have ThinRDP and ThinVNC, SparkView. Even Oracle have a client now that they've given up on Sunrays as thin clients. They're looking at browsers and thin clients, but currently they only support the iPad as far as I know. The others support, again, support does vary. So if you look at one of these solutions, one of the things that you need to check is which browsers and which devices it actually supports, because not all of them support everything or don't support everything well. And just because one doesn't support a certain platform doesn't mean that the others may not support it instead. This is my final slide. HTML5 is a whole bunch of super cool, super interesting technologies, enable things we could not imagine before being done in the browser, in the web. You know, humongous power, requires responsibility. My opinion, you know, we can't ignore this tech. Again, the only future-proof tech that's currently out there. That's it. Thank you very much.